let's talk about the notation of atoms or the notation of elements. So the way that we're going to do that is this right here with those three letters, AZX, is called the nuclear notation. And each different letter has some specific value that we assign to it. So X is the identity of the element that we're talking about. It's also called the chemical symbol. So the identity of the element. And you can see here that on the left we have the general layouts, and on the right we have an example which is oxygen. So Z is how many protons are in this element. Now the protons are absolutely critical, and the reason is protons are directly relating to the element. If I change the number of protons, I change the element. Every single oxygen is going to have 8 protons. Now, for A is just the atomic mass of the element, and is the combined weight of the protons and the neutrons. So we still do have electrons, but electrons actually weigh only about 1,000th of the weight of a proton or a neutron. So because of that, it's really not going to overall influence the weight of the atom too much. So we kind of say it's just kind of arbitrary, and we don't really need to worry about that when we talk about atomic mass. Now, the number of neutrons, we're not given that in the nuclear notation. No value here directly tells me how many neutrons something has. Now, that is completely all right, just because, like we just said, the atomic mass, A, let's just write that in, is equal to the number of protons and neutrons. So if I know the atomic mass, which I do if I have the nuclear notation, and I know the protons, which I do in the nuclear notation, I can easily figure out the atomic or the number of neutrons. So the number of neutrons will simply be the atomic mass minus the number of protons. So for oxygen, that would be 16 minus 8, means I have 8 neutrons. So we've spent a little bit of time talking about protons and neutrons, but then how do I determine the number of electrons? So as we have here, the number of electrons can be determined from the charge of the atom. If neutral, the number of electrons is equal to the number of protons. If there's a net charge on the atom, it is called an ion. So let's say, for example, I have nitrogen, and I have the same thing, nitrogen with a positive charge. The typical values that you would see for nitrogen would be 7 for the proton number and 14. So if I had both of these two examples, I would say, oh, hey, they both have 7 protons, they're both nitrogens, both have the same atomic mass, which means they have the same number of neutrons. So where is this positive charge coming from? That positive charge is going to be a result of a difference in electrons. Now I could say, hey, I have a positive charge, and I have 2 different subatomic particles that are giving an atom a charge. I have protons that are positively charged, and I have electrons which are negatively charged. So how do I know that this nitrogen with a positive charge isn't just different than this nitrogen because it has an extra proton? Well, protons, like we said earlier, defines the element. So if I had an additional proton, this would no longer be nitrogen. There would be an 8 down here, and this would now be oxygen. So that positive charge, or those charges on the ions, specifically come from electron numbers. So positively charged ions are called cations, or cations, and negatively charged ions are called anions. That's just a bit of memorization, really. Unless you like cats, then you can say they're positive, whatever. So now as an example, in the diagram below, how many protons, neutrons, and electrons does the carbon anion have? And they were nice enough to give us the numbers for both this neutral carbon and this positively charged carbon cation. So as you can see here, carbon that's neutral has 6 protons and 6 electrons. And that makes perfect sense. If I'm neutral, the positives and the negatives cancel out. 6 plus, 6 minus comes together. The overall charge is 0. Now, how does carbon become positive? So, a positive carbon means that I have lost 1 electron. If I was neutral, I take away a negative, I now am less negative, I'm now positive. So this carbon has 1 less electron because it has an overall positive 1 charge. I know I just wrote in the 1, but if I have a positive charge and it doesn't say plus 2, plus 3, it means it's plus 1. Same thing works for the negative charges. So, what does that mean for the carbon anion? Well, I still have 6 protons. My atomic mass is still 12, so 12 minus 6 protons equals 6 neutrons. Now, what does that mean for electrons? Well, I have 6 protons, and that means I have 6 positives. Now, I have an overall charge of -1. So 6 positives, if I'm trying to get to an overall -1, means I have 1 negative too many. I have 7 electrons. That's the biggest takeaway. Negatively charged molecules have a surplus of negative charges. Positively charged molecules have a lack of electrons. So now we've kind of talked about protons. If I change the number, I change the element. Electrons, if I change the number of electrons, I form ions of an element. The last ground that we need to cover are isotopes. What happens if I change the number of neutrons?